Well, good morning, educators. Welcome to SB Connect, where we connect to and educate for the world of work. Today, we are going to meet two current Ph.D. students at the UCR Bourns College of Engineering. They are Alyssa Anderson and Kimberly Uhls. The title of their presentation today is Leading the Future of Bioengineering and Chemical Engineering. So enjoy Kimberly and Alyssa today. Thank you so much.
Thank you, Michael. We will be sharing our screen now. Okay, so as he mentioned, Alyssa and I are two PhD students, and this is our presentation. So go ahead, Alyssa.
Hi, my name is Alyssa, and I'm a bioengineering PhD student at UCR.
And my name is Kimberly, and I'm a chemical and environmental engineering PhD student at UCR.
So currently I'm in my second year as a PhD student in Dr. Tori Woodruff's laboratory. She works actually in the School of Medicine. My project focuses primarily on the learning and memory changes with patients with multiple sclerosis. And I currently am funded by a NINS NIH Diversity Supplement grant. My family history, my dad is from Jamaica, and my mom, her family is from St. Thomas, Virgin Islands. So we are a Caribbean family, but I was born and raised in Stone Mountain, Georgia, with my younger brother, as you can see in the picture. I love being here on the West Coast now. I love going to Laguna Beach whenever I get the chance. And I was a former D1 athlete at Syracuse University for volleyball. So my higher education journey, I started off graduating back in 2014 at Tucker High School back in Georgia, and ended up going to Syracuse University in upstate New York to do a bachelor's in bioengineering. In my junior year, I became president of BMES, which is the Biomedical Engineering Society, the Syracuse chapter. And later on, I ended up graduating with my BS in bioengineering from the university. I moved on towards Drexel University in Philadelphia to do my master's in biomedical engineering with a focus on neural engineering, and did some research that prompted me to decide I wanted to continue on towards a PhD, where in 2020, I started at UCR as a PhD student in bioengineering. And this is a lovely picture of my current lab. We all come from different areas of research, but we all come together under the same goal, which is to solve the mysteries of multiple sclerosis. So I wanted to introduce you guys a little bit to the field of bioengineering or biomedical engineering. They're pretty much the same type of name, but at the same time, they're really just trying to bridge that gap between medicine, biology, and engineering. For myself, I want to work in drug R&D, research and development for neurodegenerative diseases. And I chose UCR because they had such a large, a lot of research focuses that I could have chosen. So UCR offers biomaterials and regenerative medicine, computation, biomedical imaging, neuroengineering, and molecular and cellular engineering, which is actually the discipline I chose. The school also offers a big program where we can work under faculty from very different areas of study that are not in the engineering field. So we have about 50 other faculty we could work with, in addition to the 18 in our program. And that is how I came into my lab, where, again, she's in the School of Medicine and the Biomedical Science Division, but I still get to enjoy some engineering aspects in that lab. Another big thing about bioengineering is that we have BMES, as you can see in the picture on the bottom, where we meet and have annual meetings, and we meet students all around the country and the world, and also people possibly in industry, and get a feel for what is the future for biomedical engineering.
Okay, so I'm gonna introduce myself a little bit. My name is Kimberly, as I said, and I'm a second-year PhD student in chemical and environmental engineering. And my research focuses on nanomaterials and aerosol synthesis. And I'll get into more about this later when we show you our experiment demonstrations. So just a little bit about me. I'm actually originally from Hemet in San Jacinto, California. So not born here, but raised in the IE. And my mom immigrated from the Philippines and my dad is from Georgia. So I am a first generation student, and I'll tell you a little bit more about my higher education journey. And just some other things about me and Alyssa really wanted to show that as scientists, we don't look like the traditional scientists you see in the media. And on top of that, we do things outside of our lab space. I like to travel. This is a picture of me from Scotland. I'm an athlete, just like Alyssa. I like to run races. And also, I once lived in Washington, D.C. to work at the D.C. Metro. So a lot of experience in different things that we try to do besides our research. So a little bit about my higher education journey. I graduated from high school in 2016 and I went straight to college in the fall after that. I was accepted to UC Irvine as an undeclared major. And this was a little tough in the beginning because I wasn't sure what to do, but eventually I decided in 2017 after taking general chemistry that I really wanted to study chemical engineering. This is a picture of me at some make-a-thon I did with some friends. And in 2018 through 2020, of course, I was still at UCI and I did a multitude of different research experiences and internships. And this one in particular is me with one of the board of directors at the Department of Energy after I completed an internship at a national lab. And in 2020, during COVID, I got to graduate from chemical engineering with a bachelor, or I got to graduate from UC Irvine with a Bachelor of Science in Chemical Engineering. And immediately after that, in the fall of 2020, Alyssa and I both came to UCR and I started my PhD in chemical and environmental engineering. And this is a picture of me and one of my lab mates working on one of our instruments in the lab. So just a little bit about the chemical engineering field. I mentioned earlier that my research focuses on aerosol synthesis and energetic materials. And so just so you all know, aerosol particles consist of a wide range of particles. And some of these particles are in the nanoscale, which we call nanoparticles. And they're actually in the air all around us. Some of them are good, some of them are bad. And, you know, COVID-19 is an aerosol particle. So that's why it's important for us to learn about these things. But did you know that they're actually in a lot of everyday items that we use? They're in paint on the walls, they're actually in car tires, and they're in sunscreen and a lot more of other things. So nanoparticles help us achieve a certain consistency of a material, which is why we study them so heavily. And specifically in my lab, we use nanoparticles, as you can see in this picture, to be put into propellants and explosives, and we study their combustion. So it's a really cool thing that we do. And that's what UCR allows us to study. That's just one of the areas that UC Riverside focuses on in the chemical engineering department. And for me specifically, my goal is to take my knowledge from my doctorate and to eventually enter the field of science policy and science communication. I believe that it's really important educating the public about the type of research that we do. And so that is what I hope to do in the future after I graduate. And I included this picture on the right because I just wanted to talk about UCR's chemical engineering program as a whole, and it can actually be heavily compared to the show Avatar: The Last Airbender, if any of you have seen it. So there's earth, fire, wind, and air. And actually, those are the 4 big research areas that we focus on at UCR in Chemi. There is air quality research. Like I said, we focus on different aerosols. There's also combustion research, which is what my lab does, combined with aerosol synthesis. So we set things on fire and see how they explode. We also have research relating to the earth, which kind of ties into bioengineering. We have plant research, seeing how we can convert biomass to additive or to effective fuels. And finally, we have water quality. How does the water move in different pipes, etc. So it's a very unique program because we couple chemical with environmental engineering. That's not something you'll see often at universities. And also it's very diverse. A lot of the faculty is very young, which is a great thing too, because of the way people think depending on their age. It's also challenging because the research is hard, and it's good to have that type of challenge. And because chemical and environmental have such like large problems that we need to tackle in today's society, that's what makes it very challenging. And finally, it is very impactful. Like I said, a lot of the research that we do ends up in very impactful journals. So that is Chemi at UCR as a whole, and that is our presentation. So now we're going to go into our experiment demonstrations, and Alyssa is going to start off.
So right now I'm about to show you guys a video where I'm doing lab research and kind of showing you the progression of a typical experiment I would run in lab. So like I said, I work on the disease of multiple sclerosis, which is a autoimmune inflammatory disease of the central nervous system. So it attacks your brain and your spinal cord. And our primary animal testing is actually mice, as you'll see as I open this container. So we are looking at both what happens in its pathology, so what's actually happening to the body during multiple sclerosis, and how we are able to treat the patients. So I started off loading drugs. We have a drug that's actually an estrogen compound, and we are right now treating these mice with estrogen to see whether or not we can reduce the effects of demyelination, the removal of the myelin surrounding our nerves, and whether or not this could be a possible therapeutic. So as we are performing these tasks, we'll have the mice, as you can see right now, it's on a rotor rod. It's a disc that's going to continuously spin. And we're trying to measure how long they can stand on the rolling disc. Basically, patients that suffer from multiple sclerosis, their spinal cord will start to lose myelin, which will then inhibit them to do basic movements. Whether that is making it harder to walk, especially run, they might suffer from some pain. So one of these tests we're doing, as you can see, is I'm allowing the disc to slowly start to rotate, and the mice will either stay on or they might fall off. If they fall off, it's more like a game for me to try to scoop them back up and put them back on the rotator. But as time progresses, the rotation will increase in speed. It's a little fun to see some of the mice decide that they're too good for this, especially if they're not being affected by MS. And they'll just turn around and just start going backwards on the rotator, which is kind of fun. Otherwise, I will run this test for about 5 minutes, and I will write down at what time they do eventually fall off of the rotator. So as you see, they're casually rolling around, but for the time restraint, I'm going to stop the experiment. And if you ever have to do research with animals, just know that they're just like any other being. You want to be delicate with them. You want to be careful with them. And it's a lot of joy to be able to work with an animal model in my research. So cute. And in case anybody asks, no, I do not name them. and no, I do not get to keep them. So the next part that should be coming up is actually a, well, as you see, I am now recording their times down. In the background, I have one of my lab mates, Micah, working on some other mice. So the next and usually the last step of my experiment is looking at the brain slices of the animals. And I'm trying to see, there's a specific part in the brain called the hippocampus, which is responsible for the learning and memory aspects of humans, as well as other animals. And for multiple sclerosis, since there is this removal of myelin on the axons, this could hinder how well we are able to learn. So I want to see how well the synapses, or the gaps between the axons, are able to fire between each other. And I am able to do this through electrophysiology. Here, it's a lot more as you would think of electrical engineering, where I'm physically putting 2 needles down on the brain slices, trying to record the electrical output, as you see right now, of the brain. I'm currently keeping the brain slice alive with a solution that is similar to the cerebral spinal fluid we have in our brains currently, and it has oxygen also flowing through it. So I'm able to take these long recordings of the brain, as you can slightly see on the right, for at least 2 hours after I've removed the brain from the mice's head. So this is very important for us to understand, again, the changes that occur if any patient has multiple sclerosis, and the possible outcomes we can expect if they are treated with estrogen. So just to give a little bit more information about bioengineering and what you can expect as a career, you can obviously, in any field, go into academia after completing a Ph.D. and finishing up with a postdoctoral position where you will continue to do research. The beautiful thing about being a Ph.D. student or a postdoc is that you do get paid, you do get funded. So you get to get paid for the research that you're conducting that is hopefully helping other people in need. But as a person in academia, you can also be helping your students. You'll be helping them learn new techniques in the field, as I learned electrophysiology in this lab, and be able to produce new and excelling research that can be taken up by small companies. You can start your own small company, by hospitals, or by the government. Like the Department of Defense is always looking for bioengineers to supply them with new technologies that will whether save a person's life in combat, or in case of any terrorist attack, any emergency aid that needs to be given, you still have positions in that field. Other ways to look at is in industry, which I am right now currently looking at. I specifically am looking into the pharmaceutical industry, where I'll be working on drug development and drug delivery. You know, from back when you were sick, you would get the bubblegum flavored liquid to drink for a cough, or you might have to take pills like Tylenol. That is all bioengineering at work right there. You could also be looking at making actual machinery. So we do have people who might have a missing limb for whatever reason, whether it's health related or from an injury. Bioengineers are capable of making materials that are compatible with the human body and are able to move around. So you will see a lot of people being able to use new legs that are made out of metal or titaniums or even hard plastics, new arms. And again, reestablishing their ability to live life normally. So there's a lot you can do with a bioengineering degree. And as you progress in your education and pursue higher education, you can expect not only higher positions in the workforce, but also a more enjoyable payout from a higher degree. For bioengineering, you can definitely expect a six-figure salary after completing a Ph.D. in most of these professions. And I believe about $120,000 to $160,000 is what you can typically find for a person who's been in the workforce for quite a while. So a lot of hard work is put into getting into that place, but if you have the right mindset and the right idea and the right focus, anything is attainable for anybody. So I really do encourage anybody who's intrigued by biology or is interested in any sort of engineering to pursue it.
Okay, so a little different from what Alyssa does. I'll be talking about my experiment today. So I'm really just setting up a common experiment we do in our lab, and that is the combustion testing of different materials. And as I mentioned earlier, a lot of times we synthesize nanoparticles, or what we call mesoparticles, in my lab. Now, these mesoparticles are normally on the micron size range or the nano size range. And what's cool about them is that we can essentially encapsulate an oxidizer and a fuel inside of a polymer matrix, which increases the reactivity. And what's important about this is that we want to be able to send rockets to space. We want to be able to have strong explosives that release a lot of energy. And that's what we try to do in our lab. And we also, if any of you have heard of 3D printing, that's something that we normally do to try to make propellants and explosive composites. So right now I'm putting a propellant explosive composite onto this substrate here for testing later on. And we actually 3D printed this composite with our 3D printers in the lab. And essentially we take nanoparticles, like I said, that we make in the lab, and we mix them with some solvent to make these thick inks that we can use in the 3D printer. We put them in a syringe and we test these later on to see with high-speed imaging cameras or microscopic cameras, because we want to see how these materials burn. Like I said, a big part of our lab is setting things on fire. So right now I'm wrapping this wire in a coil formation because we use this as a heating element. This is a nichrome wire. It is very good. It's a very popular heating element used in industry. And I'm attaching it here. It's not going to touch the sample, but it's going to be very close, just close enough that it will heat up the sample and ignite it. So I'm just attaching that here for it to be placed later on. And I'm securing this in front of, like I mentioned earlier, a high-speed imaging microscopic camera. And this camera allows us to zoom way into the material to see what the flame front is. If it's propagating meaning the flame front is going through the material in this straight formation. So we also use IR cameras in our lab. And if you can see this camera behind here, I'm not sure if you can see my mouse, that's an IR camera. And that allows us to get the temperature that the material is actually burning at, because that's an important parameter that we need to know as well. So this is the setup that we have, and it allows us to record a video. And of course, like I mentioned earlier, I attached a wire to be very close to the material because we have to send a current or a voltage through this wire in order for it to heat the sample. And so what we do is we attach that, and I press this button right over here, and you can see that the sample ignites slowly and it explodes eventually. And it's really cool to watch this. And also what's even cooler is getting to see the videos afterwards. So yeah, that is a very popular experiment that we do in our lab. And just a bit about the chemical engineering field in general. So how does UCR really prepare students to enter the field of chemical engineering and to meet the demands that society has? I'm sure a lot of you know that climate change is an issue, that there's a lot of sustainability work that we need to go through. And as I mentioned, UCR's research focuses on earth, wind, fire, and air. And these are all important elements that we have. Well, those are the 4 elements of the world. So that's why the classes that you would take at UCR really give you a strong knowledge base to tackle those issues and eventually go into different fields that relate to those things. And also, the advantages of working or going to UCR are that you're in a really central location, so you can get a job or an internship anywhere in the IE or even in San Diego, LA, Orange County. And one really cool thing about UCR in general, if you're interested in air quality, is that the California Air Resources Board actually just moved their southern headquarters on Iowa Avenue. So there will be a lot of job openings and opportunities for students to tap into the field of aerosols and air quality and really help California move towards cleaning up the environment and fighting against these greenhouse gases and, cleaning up the aerosols in the environment. So there are a lot of opportunities that you can partake in UCR. And I hope all of you are thinking about higher education. And if you're considering chemical engineering, it is a very diverse field that allows you to go into a wide range of things. If you are the beauty of an engineering degree, you learn a lot of math, you learn a lot of science, and me and Alyssa, of course, wanted to explore those further. But as an undergrad, what engineering really does is teaches you how to think and how to solve problems, and that can be applied to any field. If you want to become a medical doctor after studying engineering, you can do that. If you want to become a lawyer, you can also do that. There's a lot of different things that you can do. So that is my spiel, and I'm not sure if you have anything else to say, but if anyone has any questions, we're more than happy to answer them at this time.
As you're working on your questions, feel free to go into the chat box if you do not want to unmute yourself. I do have a question while our students are thinking about questions for you. I know you mentioned that math were some skills that you guys were able to apply in your respective subjects of research. But what skills do you recommend students work on as high school students to prepare for the engineering fields? That's for both of you.
I would say probably one of the biggest challenges you'll have is knowing how to ask for help. I would say you're not going to go into any sort of field knowing everything, and especially with engineering, where the field is moving so fast. It's very important to know that you don't know the answer, but you can talk to your TA or your professor or your teachers currently and ask for help. I think knowing when to, put aside your ego or feel like you can't talk to anybody, that you might look dumb, this is the time to get over that fear and know that these people in front of you have gone through these things and they want to help you. They want you to do better. So don't be afraid to ask questions early on, especially when you feel like you're not understanding anything, because it's much harder to try to catch up when you're falling behind than just, immediately, I don't get this, or I didn't really understand this when I was reading this paper, just going directly to your teacher and just asking is such a big skill to have going forward.
Yes, thank you, Alyssa. So if you're wondering tangible things that you can do in your time in high school to not only strengthen your application for college, but also prepare you for the world of engineering. As I mentioned, I'm a first generation student. I had no idea what engineering was. But luckily in high school, I was constantly pursuing things like hackathons or makeathons because I was interested in science and engineering. Even though I didn't know what it was, I was just curious. So if you have any opportunity to participate in some sort of coding event or some sort of robotics event, that's definitely something that will help prepare you, because while the math and science that you're learning is very important, the truth is you relearn a lot of it. Of course, it's more in depth in college, but you relearn a lot of that stuff at university. But like I said, engineering teaches you how to think. So if you can participate in events that are really teaching you how to think and problem solve, that will definitely help you in the long run for your application and also just your time as an engineer. I think that's everything. But also if you can like join a math club or something like that, I think that would be really beneficial for your education as well.
Do we have another question out there? I think I see a hand. Do I see a hand in Miss Carl's class? Well, you know, I want you to give the students an idea of basically how close you guys are in age. Let them know how many years that you have actually spent going to college, and then how close you are to actually finishing your doctorate. So give them an idea. And then you did touch on the career outlook in terms of the salary that you guys will be commanding pretty soon when you're done. Kind of give them an idea of that as well, just to give them some motivation.
Okay. So Kim and I'm 25.
And I'm 23.
Yeah, but we, like she said earlier, we met in our first year, actually in a mentorship program. That's how we met. So I've been in school now. This is my 8th year since I've left high school. Wow, that feels weird to say. But yeah, the whole time I've been in school, I did do a master's before doing my Ph.D. And I don't know, just I'm so used to being in a school environment that I haven't really thought of how much time it's been, but I'm looking towards 2025 when I can finally say I have my doctorate. Whether or not I want to continue to do a postdoc, we will see. But I know for sure, once I do leave and go into industry, or even if I stayed in academia, like I said before, I can expect a 6-figure income coming out. I know of some of my friends who went into the engineering field immediately after undergrad, and they're doing a wide range of different things. One, she went into the School of Dentistry. I know a lot who have decided they want to do consulting work. So I can say that do whatever you feel makes you the most excited and you feel most purposeful in your work. I would say don't look at a career as a way to just get money, but you're able to command a higher salary the more education you have. And that is also to say you don't have to necessarily continue on to another engineering degree after undergrad. You can always go into law school afterwards and go into patent law, or you can go into med school. You can go into the business sector and get your MBA. There are a lot of engineers who actually do that, or go into a program where you can do an MBA at the same time as finishing up your undergrad degree. So there are actually a lot of options for you to look at that are just as interesting and exciting than just an engineering degree.
Yes.
Alyssa, real quick, can you explain postdoc? I think they may not understand what that means.
So postdoc, short for a postdoctoral student. So you're in this weird in between of you just finished your PhD and then you're about to become a more senior investigator. So you're still doing research, but now you can be a little bit more hands-on in your research. You have a little bit more autonomy in the projects that you are doing, but you are still technically sort of like a student in the realm of research, I would say.
Okay. And just a little bit about my age and the amount of time I've spent in school. So as I mentioned, I'm 23. I went from high school straight into college, and that took me 4 years. So I graduated college when I was 21 years old, because I graduated high school when I was 17. And then I'm going to take about 5 years in my PhD. So hopefully when I'm 26, I will be graduating. That is a large hopefully, just because the interesting thing about a doctorate is that there is no set time. Normally undergrad degrees, they say, will take 4 years. And if it doesn't take you 4 years, that's okay. But normally that's how long it takes. But with a PhD, it can take any amount of time. But hopefully I will be graduating in 2025 along with Alyssa. And then I will be pursuing a career in industry. What was your second question, Michael?
I believe that my second question was, what is your economic outlook for yourself when you finish your PhD? How much money will you be making? Do you, on average?
Okay, on average in my career, at least, I mentioned I wanted to go into science policy and science communication. If I'm able to, penetrate the field and move higher up in my career, I can make well over six figures, like Alyssa mentioned. I won't be a millionaire, but it is a large sum of money. So I'm looking forward to that, since grad school pays very little.
Well, thank you for those responses. Many in the high school arena, they're not really clear on just how close they are to realizing their dreams and really making a great living doing what they love. And in that vein, how would you motivate current female students to consider entering the engineering field or the field of the sciences?
Just do it.
Yep.
In my undergrad, I actually joined a engineering sorority called Alpha Omega Epsilon. We're both in engineering sororities from our respective undergrads. I really enjoyed being a part of that sorority, just because I was able to meet so many other females who were interested in STEM, whether they were in engineering or not, but they just love STEM so much. And we just bonded over that love. But I have noticed that our group tends to be we have about both the same amount of males and females, at least in bioengineering. Some schools, they have chemical and bioengineering combined, and those tend to be the most popular with a higher population of female students. So just keep that in mind if you're looking for a friend. But I would say, don't be scared. Don't feel like you're not able to compete. You're accepted into these schools just as much as any other guy. And you come with a set of different perspective that is very necessary for any sort of engineer, where you have to be creative and intuitive, and thinking that that's only specific to one gender is not a good idea. We all bring something new to the table. So don't discourage yourselves from thinking, well, you see all these boys doing engineering, talking math and science, and I don't feel like I fit that realm. You do. You truly do. So please don't ever feel like you can't do something just because you might not see as many of you there as others.
Yes, I agree with everything Alyssa said. There is space for you in this field. And another thing is, there are women paving the way for other women in the field. I mean, we're trying to do that. The women older than us in our fields who actually definitely experienced that discrimination are really trying to do that. So there is space. You do belong here. And if you are passionate about something, go for it. There's always going to be someone that's going to try to stand in your way, regardless of your socioeconomic background, gender, whatever. There's always going to be someone, but you just have to keep pushing through. And like I said, there are people who are rooting for you. We're rooting for you because we were in your shoes. We kind of still are, just at a different level. So keep pushing through and do what you're passionate about.
Well, thank you for those words of encouragement. Do we have another question?
I have a question on financing yourselves for college. How have you managed to do that, and who's taking care of you now, or do you have jobs?
So in my undergrad, I actually played Division I volleyball. So I was funded by the school. I was on scholarship until I decided I wanted to focus more on my studies. I was very grateful to be able to join a lab where they had a project that was being funded. So I was able to hop on to that, and I was getting paid. For the most part, anytime I did need money, I did have to take out a loan, or, you know, hopefully my parents could help out. But since I started my PhD, PhDs for STEM majors are highly funded. So I have not had to pay anything. I had a fellowship. We both have fellowships our first year. And then afterwards, your PI, your professor, will continue to pay for you. So your tuition is covered, your insurance is covered, and then you get an additional stipend to, you know, live where you live, and, you know, if you have a car or anything like that. So I've been very blessed, like I said, to have found opportunities that have been able to fund me. There are actually a lot that you can even start looking at now. The NIH offers some funding for high school students that are participating in any sort of research. So I really encourage you to start looking into that as soon as possible. But there are ways to find funding, even though education seems like it's so expensive.
Yes. So I went to undergrad here in California, and I was actually eligible for the California Pell Grant. So this is related to FAFSA. I'm not sure if any of you have heard of this, but this will be really important for when you're applying to college. Look up FAFSA and see the type of funding that you can receive from them. If your family falls within a certain income level, you can receive a California Pell Grant. And there's also, the name is slipping away from me right now, but there is a funding program for tuition if your family falls within a certain threshold. So the Pell Grant will help you cover costs such as housing or food, but the tuition aspect will completely cover your tuition if you attend a public university in California. So please consider that if you're applying to college now. The way I was able to fund my schooling is that luckily my dad is a US veteran and he is disabled. So I have what's called the Veteran California Fee Waiver. If any of you have parents who are veterans, you should look into this as well, because it completely funds your tuition for college. So I didn't have to pay any of my tuition. And on top of that, if any of you are interested in traveling or studying abroad, the California Veteran Fee Waiver actually covers your tuition for that as well. And just like Alyssa said, for students who are interested in the science or engineering PhD track, you are more than likely going to be fully funded. It's not going to be a lot of money, but it is enough to help you, you know, live and also buy other things that you need, such as food, and, you know, kind of splurge here and there. So these are really great options. Last thing, if you want extra money, I worked all of college. I had 3 jobs at a time. But during the summers, I would apply for internships. And a great thing about science and engineering is that you will never have an unpaid internship unless you work for a city or something. But for the most part, you will have a paid internship. And a lot of times they can be a large amount, which will help fund your education if you save up the money.
That was an incredible information, and I know that blessed our students this morning. We're going to make that our last question today. If you maybe can answer this really quick, what company do both of you want to work for once you're done with your PhD? This is your big wish list. This is your pie in the sky. Real quick, Kimberly, Alyssa, what company is it?
There is no company for me. It will be a government entity somewhere in Washington, D.C. That is my hope and dream. Maybe the Department of Energy or something like that.
I have a love for Genentech. I actually was considering going right into the workforce with them before doing my PhD, but I chose to do my PhD first. So.
Well, this has been wonderful. Thank you so much, Alyssa and Kimberly. You are truly going to be leading the future of engineering. I want to say thank you to our educators and our students today. You can look for more sessions like this during Health Professions Week at sbcalliance.org. Thank you so much. This concludes our session for today. Thank you. Have a good day.
Thank you, everyone.
Thank you for having us.